Hello students, welcome back. Today we will study a very important topic of chapter number 6, that is applications of derivatives. Today's topic is the local minimum, maximum value and global minimum and maximum value of a function. So first let's study the concepts. What is the local minimum and maximum value? Let me draw a curve. Let's say this is our. Just a minute. Okay. Now let's say this is a curve. Okay. Now this point is x1. Let's say equal to a, and this point is x2. Let's say equal to b. Okay. And all the corresponding points here are fx. Okay. So this axis is y equal to fx, and this is equal to x. So now see, here x belongs to A to B. Okay, this is the minimum value of x, and this is the maximum value of x, A to B. Now see, where the curve is having maximum value, you can see that this point, this is its maximum value, right? Let's say at this point of x equal to, let's say, c, it is having maximum value, or let's say x dash. At this point this function is having maximum value, and at this point minimum value. Okay, so now what type of question asked? This value we will get maximum value of the function, and for putting this value x double dash we will get minimum value of function. Now see what type of questions can be asked. What is maximum value of f of x? Okay. Second, at what value of x f is maximum here or minimum? Also same way. Okay. So here you can say this is maximum value and this is minimum value. And at what value this f is maximum? X dash. At what value it is minimum? X double dash. Now how to find it out? Now see, you can see here at this point what is the slope of the tangent? Tangent is horizontal, so slope is 0. So at this point f dash x is equal to 0. Again at this point also the slope of the tangent is horizontal. The tangent is horizontal, so the slope is f dash x is equal to 0. So what we will do, our first step, step 1, find f dash x. Okay, so what we will do, whatever the curve will be given, we'll take its derivative f dash x. Step 2, take f dash x is equal to 0 and find x. Means when we will take f dash x equal to 0, at that time the tangent will be horizontal, means the slope is 0. So at that point you will find out this value x dash and x double dash. You may get more than one value of x such that f dash x equal to 0. So this is our answer of this second question. At this value of x, the function is having either maximum or minimum value. Okay. Now what is the maximum or minimum value? Let's say we get here, we get f dash x equal to 0 at x equal to x dash. So step 3, find f of x dash. This will be the maximum or minimum value of f of x. Now, how will you know whether this is maximum or minimum? So, for that, step 4, find f double dash x and then f double dash x dash. Put this value of x dash in f double dash. If f double dash x dash is greater than 0, then minimum value. If f double dash x dash is less than 0, then it will have maximum value. Means the value that you get here will be minimum if f double dash x dash is greater than 0, and it will be maximum if f double dash x dash is less than 0. Yeah, so these are the steps to find out the maximum and minimum value. First, find out f dash x, then take f dash x equal to 0 and find out the value of x. Then find out f x dash and f double dash x. Okay, now put the value of x dash in f double dash x. If you find out greater than 0, then minimum, less than 0, maximum. And then put the value of x dash in fx dash. Sorry, fx. Clear? Now, two types of maximum and minimum value. Local maximum and local minimum. Okay. See now, if the curve is like this. Okay. So now see, how many points? 1, 2, 3, 4, 5 and 6. So you will get 6 values of x such that f dash x is equal to 0. Okay, now let me limit it. Let me write down in short. Okay, 4 values. Let's say x1, x2, x3, x4. This has x1, x2, x3, x4. So if we put x1 maximum value, x3 again maximum value, right? So 2 times maximum. These are called local maximum. These are called local maximum value. What will be it? F of x1 and f of x3. And local minimum value will be at x2 and x4. That is at f of x2 and f of x4. But from the curve you can see that at this point, this is A. Okay, this is the starting and closing it at B. At x equal to A, it is having minimum, and x equal to B, it is having maximum. So what we need to find out? Global maximum. What is global maximum? That is f of A, f of x1, f of x2, f of x3, and f of x4, f of A. The maximum from all these. Okay, see, we got how many value? We got 4 value of x. So the maximum of all this will be global maximum, and the minimum of all this will be global minimum. Clear? So these were the concepts of local maximum and global maximum. Okay, now let's move to the exercise. Just take this screenshot of this. Now before starting exercise, let's take some extra sums. Now see, the function is given f(x) equal to 3x raised to 4 minus 16x cubed plus 18x square, and x belongs to minus 1 to 4. This is A and this is B. I'm writing down these steps. First step, find f dash x, or we'll use this f double dash x. Okay, find it this. Now find x such that f dash x equal to 0. Put that value of x in f double dash x. Greater than 0, minimum value. Less than 0, maximum value. And then put that value of x in f and find maximum and minimum values. Okay, so these are various steps. So what is the first step? Find f dash x and f double dash x. Okay, so first let me write on the function fx is equal to 3x raised to 4 minus 16x cubed plus 18x squared. Okay, now what is f dash x? 12x cube minus 16 3 is a 48 x square plus 18 to the sorry 16 to the 16 3 is a 48, 18 to the 36x. Okay, let's name this as 1, this as 2, and f double dash x, that will be equal to 12 3 is a 36x square minus 48 to the 96x plus 36. Name this equation as 3. So first step is completed. Now second, find x such that f dash x is equal to 0. That means we will take f dash x equal to 0. Now what is f dash x? 12x cube minus 48x square plus 36x equal to 0. So I can take x common here or I can take 12x common. This will be x square minus 4x plus 3, that is equal to 0. Why can I have to factorize it? 12x. Now x square minus 4x plus 3, I need to split this minus 4x. I can use minus 3 minus 1. So this will be x minus 3 x minus 1 equal to 0. Okay. So now what does this mean? Either x is equal to 0 or x minus 3 equal to 0 means x equal to 3, or x minus 1 equal to 0, that means x equal to 1. So I got three values of x. Clear? So I got the value of x. Now next step, put that value of in f double dash x. So now first from 3, f double dash 0, this one, 36 into 0 0 minus 96 into 0 0 plus 36, it will be 36 greater than 0, therefore minimum value. Okay, if it is greater than 0, that means the function will have minimum value. Now f double dash 3. Okay, so now 36 into 3 square, that is 36 into 9, so that will be 324 minus 96 into 3 minus 288 plus 36. So this will be equal to 72. Again greater than 0, so it will have local minimum value. I will write down local minimum value. Okay. Now f double dash, the third one is 1. So this will be equal to 36 into 1 square, 36 minus 96 plus 36. So this will be equal to 72 minus 29 means minus 24. And this is less than 0, therefore it will have local maximum value. Okay, so this step is 0. We found out when it will be having maximum and minimum value. Now put that value of x in f. So now first f of 0 means equation 1. 3 into 0 square 0 minus 16 into 0 plus 18 into 0, this is equal to 0. Here second f of 3, so 3 into 3 raised to 4, that is 381, so that will be 243. Now minus 16 into 3 cube, 3 cube is 27, so 16 into 27, 432, plus 18 into 3 square, that is 9. 18 into 9, that will be equal to 162. So 243 minus 432 plus 162. This will be equal to, so this will be minus 27. Now the third one, f of 1. Okay, now what is f of 1? So 30 into 1 raised to 4, 3. Minus 16 into 1 raised to 3, 16. Plus 18. So 18 plus 3, 21 minus 16, that will be equal to 5. Okay, so the local minimum values are 0 and minus 27. The local maximum value is equal to 5. Okay, but for global maximum and minimum, I also need to do f of a. So now f of a equal to f of minus 1. So this will be equal to, from equation 1, 3 into minus 1 raised to 4, that is 1. So 3 minus 16 into minus 1 raised to 3, that will be equal to plus 1. So plus 16. Okay, plus 18 into minus 1 square, that is 18. So 16 plus 3, that is 19. 19 plus 18, that is equal to 37. And f of b, that is f of 4. So 3 into 4 raised to 4. Okay, so calculate, we will can calculate 3 into 4 raised to 4. This will be 768 minus 16 into 4 cube, that means 16 into 64, that will be equal to 1024, plus 18 into 4 square, that is 18 into 16, that is 288. So 768 minus 1024 plus 288, this will be equal to 32. Clear? So now see how you are going to represent your answer. Okay, you have to write down like a local minimum value at x equal to 0 and 3, which is f of 0 equal to 0 and f of 3 equal to minus 27. Means the local minimum value are 0 and minus 27. And when does it come? At x equal to 0 and 3. Now local maximum value at x equal to 1, which is f of 1 is equal to 5. Clear? So this was about local minimum and local maximum value. Now for global minimum and global maximum. So global minimum value, this is now say from 0, minus 27, 5, 37 and 32. Which is the minimum? 0. So is at minimum of all this. That means f of, sorry, is at x equal to 0. That is f of 0 is equal to 0. And global maximum value is at, now from all this 5, which is the maximum? 37. So this is at f of minus 1 is at x equal to minus 1, that is f of minus 1 is 37. Okay, so remember For local minimum and local maximum values, you need to take that value of x where f dash x is equal to 0. And for global minimum and global maximum, you need to take all the values where f dash x is equal to 0 and also the intervals when it is a to b, f of a and f of b. Clear? So this was about maximum and minimum values. So now just note down this extra question. Okay, students, so that's it for today. In our next video lecture, we will start with exercise 6.5. Thank you.